Okay, like I said, it's a great pleasure to be back here, and I will try to be fast. I'm presenting 4 years of project in 15 minutes. Hopefully we'll have the help of the other work package leader presenting more in details of what has been done. I'll try to give you the full overview of what we tried to do and I think achieved mostly during these 4 years. So sorry for those of you that have seen this presentation already. It's like you're touring with the presentation. So the objective of this project was to build regional capacity on Earth observation in the Black Sea catchment. And we decided to do it through addressing essentially the issues of water resources in this catchment. So first, thank you for coming. And then I hope you will not regret it, that this will be a fruitful meeting. I really count on you all to be brainstorming with us today and bring your best idea on the table. This project was coordinated by the University of Geneva and enviroGRIDS, funded by the European Commission. We were more than 30 partners in 15 countries and started in April 2009. Here are the keywords taken directly out of the document of work, description of the project. So we see Black Sea, of course, water data, SDI, those are the keywords, observation, GEOS, of course, Inspire is somewhere in there. The grid also is important, grid technology. But now, where are the keywords holding our project? So we were trying to see how we could use these modern Earth observation techniques in the full Black Sea catchment, more than 2 million square kilometers, more than 150 million inhabitants. And addressing particularly the needs of 2 end users that are present in the room, and from the beginning in the project, the Black Sea Commission and the International Commission for the Protection of the Danube River. We had partners both in the catchment and in Western Europe to kind of exchange experience and build capacity. Really, both directions it happened. So we can see our project as just another drop in the Black Sea, but we are trying to trigger new ideas to change people's mind, which is not the easiest, to bring better solutions in order to water GEOS. We want to see this organization grow and become more visible and important. So our 6 main contributions to do this have been, the first one was to try to build scenarios of possible, plausible future in this region. Set the scene for the future. When we think about this, often we think climate, but that's not the only thing, and maybe not the most important thing that is changing. Demography is changing fast, and land cover is changing fast, and this probably has just as much impact as climate. So we took what other organizations have done, like the IPCC, global socio-economical scenarios, A1, A2, B1, B2, and look how we could regionalize them with storyline adapted to the Black Sea catchment. So we have here, for a global economy development in this region, the Black Sea hot scenario, or for a more sustainable pathway, regional and policy-oriented, the Black Sea pool scenario, and the Black Sea alone, or Black Sea cooperation. So we did that, extracted data. We didn't do climatic modeling, but we extracted data from previous European projects like Prudence to get regional climate models, baseline and different scenarios. And we developed methods to use these scenarios to extrapolate the value of on weather station data that we could get in the futures according, this is maximum temperature, minimum temperature, according to 2 scenarios, or it's here rainfall according to different scenarios that we are extending in the future to the end of the century. And all the data that we manage and processed, climatic data, we then made available through SDI technology, making available NetCDF type of format. Then we developed, and you will have more details on all this soon, demographic scenarios, and taking into account, according to our different plausible futures, the development in urban area or in rural area, which are, of course, different. You can have a country which is developing its urban areas, the population is growing in the urban areas, but it's going down in rural areas. It's what's happening in most places. So the end result of all this looks a bit like this, with maps of population distribution now and in the future. So we had climate, we had demography data, and we are still looking at a solution to bring all this together in an integrated way for land cover. And then our partners from the University of Barcelona and Malaga later explored possible solution and showed us that the best available technique at the moment in software was the Metronamica, to build up really scenarios of development of land cover that are taking into account a full set of modeling techniques. I won't go into details, we'll have more details very soon, but the suitability of the environment to have this or this type of land cover, accessibility from the roads or city distance and so on are being used to process the information that we know and how the land cover could change in the future. So we're setting the scene for climate, demography, and land cover in the future according to different scenarios. And then this scenario feeds into a hydrological model for the full catchment. But first we have to calibrate this model. And we chose here another nice tool called SWAT, Soil and Water Assessment Tool, which can be seen as a translator from weather information, temperature, rainfall from weather station into water quality and quantity information along a river network or per subcatchment. This is a very interesting tool for illustrating the needs of data from Earth observation, because you need all kinds of data. You need land cover, you need soil, you need climate, you need hydrological data, you need all to gather all this in order to make this possible. So that's why we chose to illustrate and showcase the needs for different sources of data to do environmental modeling. So this example came from Hungary, the small catchment of Lake Balaton, and we tried our method there. But then we had a big challenge to go for the full catchment of the Black Sea. And this challenge pushed us to, and we were right, to try to go for solutions to process this huge amount of information. So we ended up and decided, in fact, from the beginning that we will be using grid technology to not only run a model on one single computer, but on a cluster or a grid of computers. So modeling the water resources, we did it in order to serve the needs also of our two partners, end users, the Black Sea Commission. They are evolving at the moment in process of seeing how they could set targets to reduce pollution loads into the Black Sea, exploring where this pollution comes from which catchment, and then setting targets for the different countries to help reducing. At the moment, the idea in the Black Sea region, if the people allow me, is that all the pollutions come from the Danube. So the other countries don't have to really do an effort. Let the Danube clean up, and then we'll do something. So, but I think it has been done in the Baltic Sea very successfully, and at the moment the Black Sea Commission is working closely with the Baltic Sea to copy this example, and I think our model, our output could be very useful in this process. Now, we're working also with the ICPDR, and the ICPDR is probably one of the best functioning environmental commission in Europe. It's very well addressing the Water Framework Directive, and very efficiently. I was always impressed when I went to ICPDR meeting. But clearly, they are making a lot of efforts for a long time to clean up the Danube. At the end, it goes into the Black Sea, and they would like to see what's happening in the rest of the catchment. And they could also extend their know-how in the rest of the catchment. So we would like to also encourage this process. So of course the project was building capacity towards GEOS, so all the data that we have been producing, we make available, which is the scenarios, the beginning of our pipeline, like maps like this, where you have every 5 years, according to the different scenarios, a land cover map until 2050. This is the SWOT outputs. They come typically as maps like this: river discharge, precipitation, soil moisture, aquifer, and so on. You have plenty of output variables useful out of the SWOT model. Then we had other pilot studies, because the project was asking us not only to address the water societal benefit areas, but all the others. So we had to also explore pilot studies in biodiversity, ecosystem, agriculture, energy, health, and disaster in different countries. And we had one work package you will hear about that manage all these case studies, pilot studies in different countries, posters and presentation and web services data made available for all of them. And our challenge at the end was to try to wrap up all this. So everything was not possible to wrap up, but at least on the water resource front, we want to see how the output of analysis can help assess water resources. For instance, using the water footprint framework with the analysis of available water, the blue water, or water. Oh, that title is wrong. This is blue water again. I just put that up as a new one, maybe. I think it's water scarcity map, the one which you saw. And we also develop our own kind of framework to look at water vulnerability, combining existing DPSIR framework and vulnerability framework, and bringing data out of SWOT to kind of feed either framework in a quite interesting way. And the interest of that is that replacing indicators in a system like DPSIR or even vulnerability by the output of a model gives you connection between your indicators, physical connections between them that you don't have when you take a separate indicator like this. And so I think it's a very promising approach that master students of our institute developed according to different scenarios. And here we're looking at the final maps of vulnerability according to scenarios with less precipitation, with higher temperature, or both temperature and less precipitation. So this type of analysis that we can do now that we have the output of this SWOT model available. So the aim of the project was building capacity on Earth observation. So we did a lot of efforts preparing teaching material, making it available on DVD, on the internet, prepared workshop on all the countries around the Black Sea. We're very successful. Our colleague Gregory Giuliani will tell you more about that. We prepared policy brief. You have summary of all of them in your brochure. First one on bringing GEOS into practice. Second one on integrated water resource management. Everywhere we had one. Global changes with the explanation of all our scenarios. And the last one we just finished is filling the gap between data and policy. And typically, ideally, with our partners from the ICPDR and the Black Sea Commission. Our fifth contribution, even though we are building capacity project, we still think that we brought some innovation. Essentially, in the trying to bring two worlds together, the world of spatial data infrastructure, SDI, data sharing, GIS people, with the world of grid computing. And it's why our project is called enviroGRIDS, because we wanted to bring GIS onto the grid, environmental GIS onto the grid. So we have been continuing to develop our geoportal with our partners from the Czech Republic, with some innovation, being able to query different catalogs and so on, have access to the maps and data that we make available. We have been developing several applications to process data on the grid, like remote sensing data. You can, from the internet, develop a chain of analysis to, for instance, mosaic remote sensing data and process it on the grid and have the results available as web service. And also, of course, the gridded application of SWAT, porting the SWAT application on the grid. Through the internet interface, you can run a SWAT model over the grid to do the calibration and sensitivity analysis, which is very demanding in calculation. And finally, we have been trying to communicate as well and much as possible about the project. It's never enough. Somehow you have a budget, quite large budget of 6 million euros, and you would like everybody to know about what you are doing, but it's quite difficult to reach out and convince. So, first of all, we have been trying to be present with our partners at the key events, and we had, in fact, our final meeting with all the partners in Batumi in 2012 for the Black Sea Day celebration with the Black Sea Commission. We developed videos to explain the benefit of data sharing through times, and we think that really humans need to reconnect to the reality of the world and the environment in order to reach a sustainable future. Otherwise, if we don't do that, and I think Geo is the solution to do it, we will not manage. So in summary, enviroGRIDS builds scenarios for this region, is modeling water resources, is contributing new data to GEOS, trying to bring some innovation, and communicate it. So I need to thank all our partners and my team also that have been really essential in bringing this project all the way through. So thank you very much for your attention.